So now let's get started. So let's start from where we left off yesterday in the Snowflake Data Warehouse course. And now this is something where we left off. So very quick understanding or revision of what we did yesterday. So when we talk about the Snowflake Data Warehouse, so the very first layer is the cloud services layer, where these are the gatekeepers. They check everything, they validate everything. This layer is responsible for validating your queries to make sure that your query is correct, it is secure, and then it creates the optimized query from whatever request you are sending. Then that optimized query, I also want to add one more thing to what we have discussed, right? So we had discussed that I wants to go a few days back. So if anyone has any question, do please let me know. Okay. So this is the optimized query. So whatever request we are sending to the Snowflake data warehouse, first of all, that query will be optimized and something called as directed acyclic graph will be created. So this query, which is optimized, it is called as a planned query. Okay. Okay, see, this is not actually run. This is just a plan of how the query will be executed in the Snowflake data warehouse. Okay, so this is a planned query. This is not actual query. This is a plan of how the query should execute. Because right now, there could be some things which could have changed in the Snowflake data warehouse. So it is just a plan. Okay, go. So this is what we had seen. Go to that storage, take the data, do the filter, do this, do the union, and then join with another table, do the filtration, and this is how the plan will be created. But this is a planned query. So every query which is coming from here, from the cloud services layer to this FIFO queue, to the virtual warehouses, these are all planned queries, and these are all, we can say that planned queries. And on top of that, these are optimized queries. Okay? Queries. These contains a lot of details of how to execute, and where to execute from. Okay, not just what you have to do step by step, and it also tells you from how to do that things, right? How to get the data, how to do the filtration, which type of filtration to do, which type of join to use, where to execute it from. So all these things are there. The virtual warehouse does not have to use additional brain to execute it. It just takes the instruction and do it one by one, right? So these are you can say that these are planned queries, right? Okay. Now these planned queries, we had seen that these planned queries will be added one by one to this FIFO queue, which is first in, first out. This is a queue where all the queries will be added and then submitted to the compute warehouses. And first in, first out, this first in, first out means the query which was added first will be processed first. The query which was added later on, that will be processed later. Okay. So let's open the Snowflake data warehouse account. Okay, so let me see what it is. So now we are in the Snowflake data warehouse, and let us continue the discussion of the virtual warehouses. Okay. Over here, how we can find the virtual warehouses? We were in the admin section, and over here we went to the warehouses. Okay, and we started editing in these virtual warehouses. These virtual warehouses are created by default in the Snowflake data warehouse, and we have not created them. We are just looking at these default virtual warehouses which are created. So this question also might come up in your interviews as well. What are the default virtual warehouses and what are the properties associated with them? Right. And right now that you can see that I am the owner of this one. Okay? I am an account admin. You can also get it validated from that. If we go to these three dots, we can go here and we can say edit. We saw that we can change the name, we can give a comment. We discussed about the type of virtual warehouses and also the different sizes of the virtual warehouses. Okay, now let's go down. Okay, so we had discussed that the virtual warehouses are priced as per something called as credits. Okay, so each virtual warehouse usage, so how long we are using the virtual warehouse, based on its size, we will be charged in the Snowflake data warehouse in terms of credits. Okay, so credits is something how we are built on in the Snowflake data warehouse. Now we need to see something called as auto resume and auto suspend, because whenever the Snowflake data virtual warehouses are there, we do not want our virtual warehouses to be active all the time. We do not want them to be like always active, always listening to, oh, is there someone in the FIFO queue? Oh, is there someone in the FIFO queue? We do not want our virtual warehouses to keep on checking these queues and listening to the system and saying that, oh, is there something request coming up for me? We do not want our virtual warehouses to be overly active to avoid additional uh, costs, right? So there is something very great or very nice feature which is called as auto resume and auto suspend. Okay. So now, if a Snowflake data, we can give these values. There is auto resume, and auto suspend. Sorry. Um, okay, auto suspend. Okay. So over here, what we are doing is that I do not want my virtual warehouses to be always active. So what I will say, my virtual warehouse will get automatically suspended if there is some inactivity. If there is no query which is coming to my virtual warehouse, for example, for 5 minutes, for example, the virtual warehouse will go into a rest state. It will not do anything. It will not check for anything. It will just automatically suspend. It will sleep. You can say that it will take some rest. It will sleep after 5 minutes. If no one is giving work to us. So this same thing happens to ourselves as well. So, for example, the manager is giving work to us, and for example, no manager is coming to seat, or if, for example, if it is a break time, for example, we know that nobody is going to come to our seat for example, from 1 p.m. to 2 p.m. based on wherever you are, then you can take some rest. So similarly, we also want to give some rest to the virtual warehouses if there is no one coming to them for 5 minutes. So if someone does not come the virtual warehouse for the 5 minutes, we want the virtual warehouse to be in the rest state. We want them to rest. And then we want the virtual warehouses to auto resume as soon as some request hits. Okay, for example, the virtual warehouse is a suspended state, for example, 1 hour. So for 1 hour, no request was coming. So my virtual warehouse is now in the suspended state. Okay, it is sleeping. But for example, after 1 hour, the user sends some query to the virtual warehouse, and the planned and optimized query now hits the virtual warehouse. Now this query is now submitted to the virtual warehouse, and now it is automatically resumed, right? And then it will do the query, it will execute the query and will return the result, and now its work is done. And now it will again wait for 5 minutes, and again for 5 minutes, if nobody again hits the virtual warehouses, if there is no work, then it will also go back to the suspended state. Okay, so this is very good feature. So over here we can give the automatically resume, so we can read this. So first of all, let's look at the automatic suspend. It automatically suspends the virtual warehouse if it is inactive for the specified period of time. So we can decide how long a virtual warehouse should wait before going into the suspended state. You can give it in the minutes. If you want it for 5 minutes, you can give it 5 over here. And even if you want 10, 15, 20, so there is no limit to that. But if this number is small, then it is good, right? But this number should not be too huge that the virtual warehouses have to wait for like 15 minutes, 20 minutes before getting suspended. And then according to that, so here you can see that you want automatic resume. This automatically resumes the virtual warehouse when any statement that requires a warehouse is submitted. As soon as there is a query in the queue which is waiting to be submitted to the virtual warehouse, now it will be back to the auto resume state. Okay, so these are very very important things. And now, the most important thing which we need to understand right now, it is called as multi-cluster warehouse. Okay. Before that, let's discuss about how what things happened in our actual system, right? So we all have the processing power. We saw yesterday this as well. So let us go there. Okay. So this is how our systems work, right? So when the processor were coming, when i3 processor is there, i5 processor is there, i9 processor is there, there is always going to be some hardware restrictions. We cannot have 10 CPUs, we cannot have 20 CPUs. So there was a restriction in the CPUs which came out in the market. It was like we cannot have very, very fast CPUs. There was a restriction to how fast a CPU can work, because you can see that whenever we use CPUs, so let's take this box for example. So for example, this is a CPU, right? This has certain configuration. This is a CPU, and this was, for example, i9 processor, the highest processor or the best processor which we have from the Intel. Then this CPU every year, for example, and now the Intel comes to their team, they say that, okay, i9 is fine, it is blazing fast, but still I want to have the next generation of i9. I wanted it to be even more faster. But now there is a roadblock which was hit by the hardware companies. They found out that if we make our chip even faster, even bigger, then there is a problem of heat, right? Because the CPUs emit a lot of heat because they do a lot of processing power. Then the other problem was that we cannot make a CPU faster every year. So there was a limitation of the frequency. You can say that there is a frequency in terms of hertz. We had a specific limitation of how fast a CPU can process. We cannot make a CPU faster year after year after year after year. So that was something related to Moore's law. So it says that we cannot go beyond a specific limitation of the hardware. So now what company did is that because we cannot increase the size of CPU or we cannot make it more powerful, we came up with something called as multi-core CPUs, right? So now what happened is that one CPU is now consisted of multiple cores, right? So that is why you can see that Intel processor come with multi-cores, right? So now what they did is that instead of having one large CPU, they segregated one CPU into multiple cores. So they say that, so now this is what you can say that if you are curious and if you might have looked at the CPU ads, they have multi-cores, right? So instead of just one core, they created multiple cores. They said that, okay, instead of having more powerful CPU, even increase instead of creating more powerful CPU every year, we will add more cores. And now each core is equivalent to the CPU. Okay. CPU power. So right now, if we have four cores, so each core will have additional or equivalent power to the actual CPU. Okay. So now, for example, if this CPU, if we talk about one CPU, so it was working, it had only one core previously. So it had some frequency, right? So for example, 2.3 gigahertz, any value. Okay. So now this was the power of a single CPU. And now once we have created something called as core, each core has same strength, right? So core one can also work at 2.3 gigahertz. The core two can also work at 2.3 gigahertz. So this is how the companies found out a way to have more powerful CPUs, right? So now every year they come up, they do nothing. I mean, they do a lot of things in their terms, they do a lot of optimization, but they add more cores to existing CPU, right? So each core is now working like a specific or a full processor which had full powers, which was there when we were working with one processor. So now you can see that instead of one processor, we have now attached three processors to that CPU, and now we have got four times the power. It will be four times the power which we had previously, right? So the same concept also applies to the virtual warehouses. How? Let's see that. So the compute virtual warehouse is in all, you can think of it to be a single CPU which has a lot of power. We talked about the size of the virtual warehouse. For example, this has its own processing power. For example, it is of the large size virtual warehouse, right? So it will have its own compute methods. It will have its own memory. It will have its own cache. It will have its own hardware components, right? So now over here, we also have the same problem. We cannot make our these um, virtual warehouses really, really fast. We again are hit by the same roadblocks. So now we can also have something called as cores in the virtual warehouses as well. For example, if this is your virtual warehouse, you can think of it to be the same way. So I'll show it over here in the same terms. So for example, this is your virtual warehouse. Because the virtual warehouse is nothing new, right? The virtual warehouse are somehow in the backend are also using this hardware technology which you have. This is nothing revolutionary. Okay. Okay. So just the usage of this virtual warehouse management and maintenance is new, but the implementation of the hardware is going to be the same, right? So previously, if we talk about virtual warehouse, you can think of it to be a single CPU, which we had, right? But then on top of that, we can also create something called as cores. You can have that. You can also have additional cores in your CPUs, right? Just like in your CPUs, you can also have multiple cores in the virtual warehouse. They have different names. So if you want your virtual warehouse to be even faster, we have something called as clusters. Okay, so the term is different. So now instead of having just one cluster, I am now adding more clusters to my virtual warehouse. So for example, I add one more cluster. I can add up to 10 clusters. Okay, so I can have from one cluster minimum, of course, to maximum 10 clusters. So for example, in this system, I will say I will have cluster one, I will have cluster two, and then I will segregate or I will make my virtual warehouses more powerful by adding more clusters, right? So this is something you can compare it to the cores of the CPU. So now each cluster will be working independently, and now your entire virtual warehouse is now even more powerful. Okay. So if you look over here, so this is now your virtual warehouse, which has even more, which is now even more nicely powerful. So over here, I'll mention over here, cluster number 4. Okay, so each cluster will be very powerful. So previously we had one virtual warehouse. For example, previously we had this virtual warehouse which was of the size small, for example, or large, any size you can think, right? So for example, we had a virtual warehouse. We had only one virtual warehouse, and it was kind of whatever name it is, compute underscore. This is the name, compute underscore warehouse, and its size was, for example, small, right? But now we can also make our virtual warehouses faster by adding more clusters to it. And each cluster will behave as a dedicated virtual warehouse of the same size. So now, instead of having one small virtual warehouse cluster, I am adding more cluster, and all these clusters are capable to be equivalent powerful to the single virtual warehouse which we already have. This is how we can add more powers to the existing virtual warehouse. It has not added a more virtual warehouse, but the warehouse which we had, it now has more cores, you can think of it. Now it has got more clusters, and now the clusters are providing more power to the existing virtual warehouse, right? And now the billing will also be 4 times. For example, if we talk about small virtual warehouse, so let's look at it. It is now 4 times powerful, right? So previously we had only one small cluster of compute resources, but now in the same virtual warehouse, so it is also compute underscore warehouse. Okay, so compute underscore warehouse. So this is also the same virtual warehouse. It also has the same name. So the name has not changed. Nothing is changed. Just now it has become more powerful. Instead of previously having one cluster, now it has got multiple cluster, and each cluster is as powerful as the single virtual warehouse which we had previously. Okay. But the billing will also change. Over here, we discussed billing previously because it was just one small size virtual warehouse. And for example, we saw that it is 2 credits per hour, right? Right. So this was the billing previously. But now we have 4 clusters. Each of the cluster is of small size. So the billing will be 4 times the small size, right? So now the billing will be 4 into 2. So each cluster, we have 4 cluster, each cluster has 2 credits. So it will be 2 credits per hour. Okay. So over here, you can see that although we have increased the performances or we have increased the power of the virtual warehouse, but of course, now we will have to also pay more for that. And these clusters, multi-cluster which we have created, we can create clusters we can have cluster maximum 10 clusters. Okay, we cannot have more than 10 clusters in the virtual warehouse because the billing will also become very, very difficult to manage, right? You can think of it if we have 10 clusters in the virtual warehouse of the small size, then the billing will be, for example, it will be 10 into the small size, right? So this is what we can see, right? And now very interesting thing. For example, if we come to this virtual warehouse settings and we change the size of this virtual warehouse from small to large, right? Then all the clusters will also go from small to large, right? So you can see that it is very, very similar. So we do not see these clusters are not different from the actual virtual warehouse. Whatever performances or whatever settings we define at the virtual warehouse layer, it will affect all the different clusters, right? So they are a replication of the existing virtual warehouses, which we have already created. So over here, if we come here, so this is where we can define multi-cluster warehouse, whether you want to increase the power of your virtual warehouse. This is a single virtual warehouse to which multiple clusters will be added. So here you can see that how many minimum clusters you have. You can have minimum any number. You can have minimum one, and maximum you can go up to 10, right? So for example, the example which you are looking right now, the maximum cluster is 4. We have created 4 cluster of the virtual warehouses, right? So we do not, so now our virtual warehouse is 4 times powerful. It is having 4 times the more resources. Now it is 4 times expensive as well, right? So you can think it like this. It is everything is now 4 times. It is boosted up. So we have boosted the performance of the virtual warehouse 4 times, right? Okay. Now, you can think of it, okay, if I have 4 clusters, for example, okay, I have made my virtual warehouse very, very powerful. And now my virtual warehouse has 4 clusters. So how are these clusters going to be used? For example, if there is one request coming, which cluster will take this one, and which cluster will all cluster work together? For example, if there is a query, so if there is a query submitted, right? This is with what we have seen, right? A query, it's a virtual warehouse. Previously, it was one box, but now the virtual warehouse is having 4 clusters. So now you might think that, okay, if there is a query one coming to the virtual warehouse, which cluster will it work with? Will all clusters be active all the time? If I say that we discussed that the we can decide that virtual warehouses can go automatically suspended and automate and always all will be active. So you might be thinking that, okay, if a query is coming, does that mean that all the clusters will be active all the time, or which cluster will be active? How will it work, right? Okay, I have got a very powerful system, and but how is it all working at the back end? When will a specific cluster start? Whether all of them will be active, whether all of them will be deactivated, how these things work at the back end. For that, we have very important thing which is called as space scaling policy. So the scaling policy dictates how these clusters are going to be managed and how and when a specific cluster should be activated. Okay, so let's create let's do this diagram. Okay, so this is our virtual warehouse, for example. Okay, and this is a queue which is coming. Okay, so this is the queue which is coming to the virtual warehouses. Okay, so we can make it like this. For example, this is a queue which is coming from the, you can think of it to be coming from the your cloud services layer. Okay. Okay, so now this is your virtual warehouse, and I can even delete it, right? Not required. So this is a compute warehouse. This is the name of the virtual warehouse. We have added 4 clusters to this virtual warehouse, as we can see over here. Okay. So we are seeing that the virtual warehouse which you have, it is not a normal cluster. I wanted to have more power, so I'm making it 4x powerful. So minimum cluster is one. Minimum cluster is one. Okay, that's fine. We can have minimum one, and the maximum cluster is 4, right? So 4 is the maximum cluster. And we have something called a scaling policy. So let's discuss about this scaling policy. Now we have 2 scaling policies. We have standard scaling policy and we have the economy scaling policy. Okay. Okay, let's talk about it. So we will now talk about the scaling policy. Okay, so very first one is the standard, and the second one is economy. Economy. Okay. So here, let's also see one thing. The standard one is the default. Okay, so it prevents or minimizes queuing of the loads, and this standard is default. So by default, this standard scaling policy is default. So these things I'm mentioning because these questions might come into your interviews as well. Okay. So let's talk about the standard scaling policy. How the clusters work and how the virtual warehouse decides which cluster should be active, which cluster should not be active, and how these clusters actually work at the back. For that, we have a very nice PPT. Okay. Okay. So now let's talk about multi-clustering. Okay. Very interesting topic. Okay. So now the standard policy, which is the default, it prevents, this is just a description, it prevents or minimizes the queuing. So by favoring starting additional clusters over conserving theirs, right? Okay. Let's understand this step by step. It prevents, we will just repeat it. It prevents or minimizes the queuing by favoring starting the additional clusters over conservation of the credits. So the standard policy says that I do not care about what is going to be the bill, right? So even if I have to pay for more credits, that is fine, but I want the best performance. I want minimal waiting time for the processing of the query. So this is the motto of this scaling policy. So processing, minimal waiting time is priority. Okay, so the customer should wait as little as possible for their queries to be answered. I do not, and it does not care about the billing. So it says that, okay, it's just like saying that, for example, you go to a restaurant, right? So for example, you have a lot of money, you go to a restaurant and you take your very best friend, which you have met for like after 5 years. She will say that, okay, I will order anything you want. I do not care about billing. I do not care about anything. And the restaurant people also say, for example, it is your restaurant. You also go to the restaurant manager. You say that I am here. I do not care about billing, whatever billing, how you are going to manage the food. I want minimal time for my friend because that friend has visited me for a very long time. I want us to have the best experiences. I do not care about billing. I have a lot of money. Don't worry about it. I will take care of the billing. Even if you have to go outside, purchase some anything, even if you have to purchase something from outside, you purchase it. I do not care. I want a specific flowers. I want this kind of decoration, and I want everything to be done on priority, right? So these are the two mottos of this scaling policy. Okay, it does not care about the billing, because now and then it takes care of it, ensures that the waiting time is priority. Now let's go to the next point. Okay, we will talk about this all. Now you will see how the entire thing works. How does the cluster start? So by default, you can say that by default, all the clusters will not be active, right? This is something we have to understand. By default, all the clusters are not active, right? So now let's see how the cluster actually starts. The cluster starts immediately when either a query is queued or the system detects that there are more queries than can be executed by the currently available cluster. Okay, so for that, we have to go back up step back. Okay, so where did I mention that? So we discussed about that. There is a planned query which is submitted by the cloud services to the virtual warehouses. Whenever these planned queries are created, there is also something called as planned execution time. So now, whenever a planned query is created, a time is also associated to that. So this is how the query should run, and it should take, for example, 2 seconds to execute. Okay. So with each planned query, we have a planned execution time, which is kind of, you can say that, which is assumed by the cloud service layer. Okay, this is this query, this is the plan, how we will execute it, this is the steps how we can get everything. And to do all these things, I think it should be fair enough to give 2 seconds to execute this query, right? And now over here, we will see that in this queue, the task will be added, the queries will be added. Along with it, they will also have estimated time of how long this query will take, right? And in addition to that, each clusters also have some good amount of time, right? So for example, if it is a large query, it can handle query very easily for up to 5 seconds, right? It can execute queries. I mean, it can execute them very, very easily. For 5 second query is very nice. But if you give it a query for more than 5 seconds, then it may take even more time, right, to execute. So for each cluster, we have specified a time for which it is good or it is able to execute the queries very, very nicely. Similarly, cluster, because these are all of same sizes, the cluster 2 can also handle queries 5 seconds very nicely. And similarly, cluster 3 can also run the queries very nicely for 5 seconds. And then cluster 4 can also run the queries for 5 seconds. Okay. Now let's consider there are three queries. The query 1 is for 2 seconds. Query 2 is also provided. It is good for 1 second. And then query 3 comes. It is good for example, 3 seconds, right? So now what standard scaling policy says, what we have read over here, the additional cluster starts immediately when either a query is queued or the system detects that there are more queries than can be executed by the currently available clusters. For example, okay, so let's do it one by one. Okay. So for example, query one comes, query one is now the very first one and our minimal clusters. So very first time our cluster one will be activated and this query will be submitted to this cluster one. Okay, now it is doing it. Now, similarly, at the same time, plus query 2 comes, it takes 1 second to execute. And now our Snowflake Data Warehouse Cloud Services layer know that this cluster can handle up to 5 seconds of query very, very easily. So this query 2 is also submitted to this cluster. And then query 3 comes, this query is going to take, for example, 3 seconds. Now the cloud services will see, okay, I have already submitted 3 seconds of queries and it is still working on it. And if I give 3 seconds more, then it is beyond its capacity, for example, right? So it will take a lot of time to execute. So let's do one thing. I will give this query three. So I have given query one, query two to the virtual warehouse one, to this cluster one. Now let me do one thing. I will give this query three to the second cluster because I want the best performances. I do not want so someone who has given the query 3, I do not want that person to wait any longer. I want that person to have the answer as quick as possible. I want to give minimum waiting time. I do not care about the billing. Either if I have to provide more billing, I will start a addition cluster and this query 3 will be given to this one. And next, for example, there is a query 4 which takes, for example, 10 seconds, right? Or even less than that, or you can say that it takes 5 seconds or 4 seconds. Now the virtual warehouses way, okay, we'll see that cluster one is busy. It already has queries. And then cluster two is also busy. Let's do one thing. Let's start this cluster three and give this query to cluster number three, right? So this query will now go to this cluster. This is how the clusters will get activated one by one, and based on the capacity of the virtual warehouses, these queries will be submitted to that specific cluster. Okay, but right now the cluster 4 is not active, right? Here you can see that only cluster 1 is working, cluster 2 is working, cluster 3 is working. And now, for example, if there is a query 5, for example, that query 5 takes 2 seconds, right? Over here, it will see that, okay, cluster 1 is busy, cluster 2 is busy, cluster 3 is busy because they already have a good amount of load. Nobody can kind of accommodate cluster 1 can accommodate, right? 1, 2, 3, 4, 5. So now it will say that, okay, my cluster 1 is not that much busy. It can take up to 5 seconds of execution, but still it is doing only 3 seconds. So let me give this query 5 to the cluster one, right? But still cluster four is not required. And now each cluster is running at its full potential, right? So this is what it means if we read it again. So the cluster starts immediately when either a query is queued, right? So this is what we had seen that in case of queue cluster one. So as soon as query one was submitted, so the query one was given to the cluster one. As soon as something is in the queue, it should not wait. Nobody should wait in the queue, and that a query should be assigned to one of the clusters, right? Okay, so immediately when either a query is queued or the system detects that there are more queries that can be executed by the currently available cluster, right? Okay, that's fine. And now this is how the virtual warehouses clusters are now working. And now, of course, they should also close down back, right? So they are not going to work always. So now the clusters also shut down after 2 to 3 consecutive successful checks, right? So there are checks which are performed on the virtual warehouses and they are done after every 1 minute, which determines whether the load on the least loaded cluster could be redistributed to other clusters. For now, as the time goes by, you can see that first of all, this query will be completed and then this query will be completed, right? This will take 2 seconds. And then you can see that cluster one become free, right? So this is how, as the cluster will keep on completing their tasks, they will become available. Now, for example, the next query, okay, this query 5 is still there. So for example, cluster 1 has completed everything. And then query 3 is also done. So this warehouse is also free. Oh, sorry, this cluster is also now available. And then finally, when the query 4 will be executed by the cluster number 3, and then this cluster will also get free. Your queue will be empty and everything is back to normal. Okay, so this is how when the query comes, it will be redistributed across the clusters. And but you should this scaling policy decides that no query should be waiting in the queue. As soon as a query comes, I need to assign it to an available cluster based on its capacity. Okay, so this is something called as standard scaling policy, and this is a default scaling policy in the Snowflake Data Warehouse virtual warehouses. Now, let's talk about the economy policy. As the name suggests, we are going to be economical in over here. So over here, we do care about the billing, about the billing. Okay. So if we care about billing, if we care about how many virtual warehouses are going to run, then we are going to be okay, okay for making the queries wait, right? Do you agree? Over here, you can see that even if some queries have to wait in the queue, I will not worry about it because I am concerned about billing more. I want to be very optimal usage for these clusters. I am fine if some queries are waiting in the queue, but my cluster should be used as long as possible. It is possible, right? So over here, so now the economy policy, it conserves credits by favoring keeping running the clusters fully loaded rather than starting the additional clusters, right? It may, so here you can see that there is a negative thing associated with it. It may result in queries being queued and taking longer time to complete. So a cluster starts only if the system estimates there is enough query load to keep the cluster busy for at least 6 minutes, right? So over here, it is now waiting for more time. So for example, if your cluster can take up a load for 5 seconds, but it will add 1 second to that. It will say that, okay, even if this cluster can take up to 5 seconds, I will make it, I will give them queries for 6 seconds. For example, the query one comes, query one come takes 2 seconds. Then the query two comes, query two, for example, takes 3 seconds. So now the virtual warehouses, first of all, these both the queries will now be associated to the cluster number one, right? So this is how it will work. So you can see that although in the previous one, in the standard scaling policy, the virtual warehouse 2 could have been given this second query because it is beyond its scope, right? So in the previous one, standard policy, what it could have done, it could have started the cluster 2 and could have given the query 2 to the cluster 2. But over here, because this is an economy scaling policy, we want to restrain from starting additional clusters. So that is why the cluster one will be also assigned these two queries. And over here, you can see that the cluster one is not able to perform both the queries at the same time. It first of all has to do query one. And once the queries one is completed, then it will start working on the query because it cannot handle 6 seconds of query at the same time. So here you can see that the query 2 will have to wait as long as the cluster has completed or finished the query number 1. Now, once the query 1 is complete, now query 2 will be submitted to cluster 1. So over here, we have seen that we have not started cluster 2. If it could have been the standard scaling policy, it could have assigned query 2 to cluster 2, and we could have to pay more because we are using double the resources because we didn't care about the billing in the previous one, and we our priority was the minimal waiting time in the queue. But in the economy policy, we do care about billing. We do not want to additionally start the cluster suddenly, and we are okay to make the queries wait in the queue of the queries. Okay, so are we all good? I hope you have understood. Any questions around this? Are we all good? Else I'll start asking questions. Okay. Murli, Tejendra, Naveen, Surekha, Mahalia, Rakesh, Pritam, Radhika, Rupali, Mayappan, Botru. Are we all good? Oh my God.
Yes.
Okay, are you
Yes,
good?
sir.
Okay.
Yes, sir.
Surekha, are you good? Rakesh? Okay, Mayappan,
Yes.
thank you. Pritam, are you good?
Yes, sir.
Okay, thank you. Okay. Don't call me sir. You can call me Vipul. I do not want to be called sir. Okay. Okay, thank you. So this is something, this is very, very important. This is the scaling policy which we have in the virtual warehouses. Okay. So now if we again go back to the creation of the virtual warehouses, so over here we have the ability to decide what you want. Where do you want the scaling? So scaling, right? Scaling is like 1, 2, 3, 4, 5, 6. How you want, you are scaling something, right? You are increasing something. So the scaling policy is standard. So over here, they have also given this thing. Now you will understand the scaling policy prevents or minimizes the queuing of the workloads. So queue should be minimal as possible. Less and less number of queries should be in the queue. Whereas in the economy policy, it conserves the credits by running the fully loaded cursor. So it is very nice that the Snowflake Data Warehouse is also given the description over here. Let's go with the default. Okay, another important thing is the query acceleration. Okay, so and you can see something called as scale factor. Okay, for that we will have to go back to the optimized query. Okay, so for now, for example, whatever query we submitted, for example, query one is there. For that, a DAG is created, and that DAG says that, okay, first of all, the step one has to be done, and then, for example, step two has to be done, and parallelly, we can also do step three, and then we have after step three we have step four, and then after step two we have step five, and then after step five we have step six and step seven. So this is kind of a weird. Um, this is we can even add more step seven, step eight, and then step nine. These steps can be anything which we have discussed. These are kind of an instructions which are created for the virtual warehouses, right? So we have step one. So let me quickly do this. So first of all, step one will be done. And then after step one, step two, and step three will be done. And because they're independent, they can be done parallelly, right? And then this will happen. And then step two, after step two, step five will happen. And then after that, we will have step five, after step six, step seven can be done parallelly. So that is why this is now you can see that this is a tree-based structure, right? So step three, step four, and for step four, we have the step eight and step, oh, sorry, we have step eight twice. Why? We have to read it to step nine. Okay. So now let's say whatever query we are sending to the Snowflake data warehouse, this is the query which has been created. This is the estimated query, right? Estimated query, and estimated query has a completion time. For example, this query takes 2 seconds to complete. This is not just at the query level. The Snowflake Data Warehouse also estimates how much time each step will take. Right? For example, this step will take 10 milliseconds. This will take, I just want to give an example. So for example, this will take 10 milliseconds. This will take, for example, 30 milliseconds. This will take, for example, 15 milliseconds. This will take, for example, 5 milliseconds, for example. So each step also has a time associated to it, right? So 8 milliseconds. And then now, if we come here, for example, 14 milliseconds. I'm not doing the math, right? So just to give you an idea of what actually happens over here, right? So 80 milliseconds, and then we could have something called as step 9, and it is kind of, you can say that 70 milliseconds. Okay, so this is how an estimated query in the Snowflake data warehouse works. And now why this is actually called as a DAG, because this is a directed graph. It directs which direction to go, one after the other. And then on top of that, it is acyclic graph. It is directed, you can see that we have directions, and it is acyclic because there are no cycles involved. We are not saying that first of all go to step one, and if it goes like this, for example, if we have something, we need to reverse this. Oops, what is this? One second. This is a cyclic graph. If, for example, the step seven says that we have to go back to step number two, right? This is not acyclic. Now this is cyclic. This is a cycle which has been created. First of all, step one will happen, then step two will happen, then step 12 will happen, then seven will happen, then again step two will happen. This is a cycle which has been created between step two, step five, and step eight, step seven. Okay, so this is cyclic. But because this is acyclic, we do not have any cycles between anything. It is straightforward. So we cannot see any arrow which is coming back to the previous step or to the first step, right? So that is why it is called as acyclic, because it is not cyclic in nature. Okay, so now we can see that in the Snowflake data warehouse, we have two processings, right? So this is what I mentioned over here, which not many people discuss about. So in this Snowflake data warehouse, okay, where is that? I created something very interesting. So the architecture. Okay. So in the architecture, we discussed that in the Snowflake Data Warehouse, we have virtual warehouses to process our queries. On top of that, we also have serverless compute engine. This is also an engine which is over there, which is available on the demand, and we also have to pay for that, right? So now the virtual warehouse, when the virtual warehouse will get this query, right? The virtual warehouse will get the query and will come to know how to execute something. And then it will find out that, hey, why this step is taking a lot of time? This is the step which is taking maximum time, whereas the other steps are taking very, very less time. Can I do something about it? So now using the query acceleration engine. So here you can see that it accelerate the outlier queries. So outlier queries is something which is taking a lot of time as compared to the other steps. So here you can see that because the query will not complete on its own until unless all the steps are done. We cannot say give the user the result of this part. We cannot say that okay, we have the partial result which is this one, and this step 4, step 8, and step 9 are dependent on step number 3. So these steps, although these steps are small, they will not happen as long as this step 3 is complete, right? So that is why this is some outlier queries which is taking more time than the expected steps out there with the additional flexible compute resource. Now, what we will say to our Snowflake data warehouse that please, in addition to the virtual warehouses, also dedicate some place which can be used for these kind of additional queries, right? So we will say that there is something called as compute resources, additional compute, serverless compute resources, serverless compute resources. So this is something we want it on top of the virtual warehouse compute resources, right? Resources. So now these compute resources will then be associated to the virtual warehouse which we have, right? So this is something, this virtual warehouse then will be associated to this serverless compute here. Okay. So let me associate them. So we want to associate this additional serverless compute resources. So we have now associated them. Okay. So now you can define it, how big you want it to be, how big you want to be, whether you want it to be 8 times the virtual warehouse, whether you want 17 times the virtual warehouse, whether you want it to be 43 times the virtual warehouse, or you want to be no limit. Okay. So the default, let's take it 10 times the virtual warehouse. Okay. So now this is some power of the virtual warehouse, right? So we have got some power in the virtual warehouse. So this virtual warehouse, for example, has power of, for example, 100 horsepower, right? 100 horsepower, and it is able to do these queries very, very faster of the horsepower 100. Now we are seeing that we want a query acceleration. We want to accelerate our queries, and we will use some compute resources. I want to, you can say that I want to have additional place, which you can also do the similar thing as the virtual warehouse, but this is very, very scalable. So I want it to be 8 times the virtual warehouse or 10 times the virtual warehouse. So this time we have selected it to be 10 times. So it will be 100,000 horsepower. This is the power. But again, this is only available on the demand. It will not always be available, but this will be available on the demand. So now when this query is submitted to the virtual warehouses says that there is a step which is going to take a very long time because I have only 100 horsepower. If for me it is going to take 1 second, but if I give it to someone else who is more powerful to me, and this place is also available for me whenever I want to use it, then why shouldn't I give this step one to this serverless computing? If I am able to do it in 1 second as per the planned query, this is going to take 10th of the time. So he can do it in 0.1 seconds, right? So what I will do, I will do step number 3. Meanwhile, I will give this step 3 to this computer resources. This is going to do this step. And on top of that, I will do step number 1. So this cluster 1 will get the query because it is less than 5 seconds. So any scaling policy we need. Now this step 1, step 2, step 5, step 6, step 7 will be done by this virtual warehouse, whereas the compute resources will be doing this query in 0.1 seconds. It will do the processing and will give the output to the virtual warehouse. And then the virtual warehouse will do step 4, step and step. This is how we can have, and then once the step one is done, this resources is now not used anymore. So we will not be built at all. Okay. So this is how we can have the query acceleration whenever we have a specific set of instructions which a virtual warehouse cannot do. We can have it done by the additional resources which we have, and they will do the processing for the virtual warehouse, and that will then return the result to the virtual warehouse so that virtual warehouse can then proceed further. So over here, you can see that the estimated query time was 2 seconds, but because this step was now done in 0.1 second instead of 1 second, this query has been accelerated. Now this query has completed in, for example, 1.1 seconds, right? So this is why we call it as the query acceleration, because our query has been accelerated. The estimated plan was 2 seconds, but the actual execution time is now 0.1 seconds, right? So over here, we can also see that the way of how the query was executed also changed, right? So now you can see that over here, we will see this was the estimated query plan. We will also have something called as actual query plan, a query plan, right? So this is how our cloud services wanted the execution of the query, but then internally this was executed differently from what was expected by the cloud services. It has taken less time, it has taken 1.1 seconds, and the actual query plan is going to be different from the estimated query plan. So it will not be the same like this. So now it will be, for example, this was done by the virtual warehouse. So virtual warehouse has not done this, right? So now let us make it like this. And then this will be done directly from head to head because the virtual warehouse just got the results and then it executes this. Okay. So now here you can see that there are two things. One thing is the estimated query plan, which was created by the cloud services layer, and there is an estimated execution time to each and every query of how it is going to be executed. Whereas now it also depends on the virtual warehouses. It could offload some of its capabilities to the serverless compute engine, and its plan will now be the actual execution plan is now different from what was estimated, and the estimated execution plan is also reduced, and we have the query acceleration. That query is accelerated. And you can also make it as 0 or 1. Okay, if you want, you can also increase it. So this is how we can make our queries optimized. And these are all the properties which we have associated to the project. I hope everyone is comfortable this time. And we have understood a lot of things, because understanding this actual query plan is very, very important, because it tells us how the query was actually executed. This may not make a lot of sense for you, because right now you can see the plan, but right now the query is not actually executed. So the actual query plan makes more sense. It tells you how a query was executed at the backend. We will also see how we can see the actual query plan and the actual, this is not actual estimated time, this will be actual execution, actual execution, which has taken for the virtual warehouse to execute a specific query. Are we all good? So this is all about queries. I will not bore you with more details. So once you have understood all these technical nitty-gritty of how the things actually work, understanding the Snowflake data warehouse is going to be very, very easy, because people these days do not try to understand these things, and they go in interview with some features by learning some features and telling those features to the interviewers. And then once the interviewers go down one level, two level down, or they ask about more technical details, they do not understand how things even work in the backend, right? So once you have the idea of how the things work, how the cloud services work, how the query is created, how the query is then added to the queue, then how they are taking from the queue based on the clusters, and how the virtual warehouse can also decide to offload some of the tasks to the serverless computing. Once you have a good idea, then now the Snowflake data warehouse is going to be very easy thing for you, right? All good? Are we on the same page? Are we all good? Okay.
Yeah.
Radhika, Rupali. Okay. Meyapan, Naveen, Tejendra, Murli, Surekha, Pritam, Melia, Putru. Any questions?
Yeah. Hi, Vipul. This is
Yeah. Hi.
Surekha.
Yeah. Hi, Surekha.
May I know the fee of the course?
Oh, sorry. For that you will have to contact the DataVision. Sorry, I cannot
Okay.
help you. Okay.
Yeah.
So
Okay. Okay.
so one thing which I want to mention over here. Okay. Anyone has any question before that? Before closing. Okay, so this video which we have right now, we just had today from 6:30 MIST. So this video is also going to the channel of the Data Vision. So if you want, you can go to this channel, and this video will come up somewhere over here in the beginning, and you can register for this course. If you have any questions, you can go to the website. So you can also see their links. So you can connect with Facebook, Instagram, LinkedIn, Twitter, website. So this is the official website. You can also have the Play Store and the App Store as well. Okay. So if you want to have any questions with them, you can go to their website, their official websites, and over there you can see more details or you can get the career guidance as well. Okay. So if you come down, you can get the details about them. Okay, so we are in the Bengaluru. This is the phone numbers if you want to have any questions. If you have any questions associated to any course. So right now, the course which we are in right now, it is called as AWS Data Engineering with Snowflake. You can ask any questions. And if you have any questions additionally, you can also request yourself to be added to the WhatsApp group. We have lots of information to share, and we will keep sharing these details and providing all these details. So we also need an active participation from your side as well, so that we can all group together, right? So that is it for today. So that was the end of the free sessions we have for the Snowflake Data Warehouse. For others who will continue, we will continue from here, from wherever we are left off. And then for others, if they found if they found these videos interactive, useful, then we are very thankful for giving us the opportunity to give us the overview of how we teach and what we teach. And hopefully you liked our presentations and you would like to have a future discussion with us. And if you have any questions, you can, yeah. Okay, yeah, Miyapan, sorry. I will share this PPT on the WhatsApp group, which we already. Okay, okay. And I mean, it's fine if I even share it over here, not a problem because they are all the demo sessions. So thank you, Miyapan. I'll just share it in this group. Let me save it. And then let me give it on the, where it is. Yeah. Okay. Okay, so I hope, yeah. Can you say it now? Meopan? Oh, sorry, I just shared it with you. Share it with them. File. So everyone, I have just shared the PPT which I have used for the last 5 session of the Snowflake Data Warehouse. So just in case if you go through the videos, this is going to be very helpful to you. And I hope you enjoyed today's session. Thank you so much for joining. Have a good day.
We will.
Hope to see you again. Yeah, yes, Radhika. Sorry.
I have one doubt, Vipul.
Yeah, please,
Uh,
please.
you told that virtual warehouse will support only 10 clusters, right?
Yes, maximum 10 cluster we can have.
Maximum 10 clusters only. Actually,
Right.
I have one doubt. In my production environment, we have an
Mhm.
extra small warehouse.
Right.
When I saw, it will show, right, how many clusters it is using to run the query.
Right.
When I
Problem over here is that you might not have the full access, right? All these details can be seen by the administrator, right? So over here we will see how you can. So here you can see that, right? We are using the
uh,
administrator panel. So you might not be able to see this administration panel. You might not be able to see this. You
I
will
am
not be
able
able
to
to.
see this.
Mhm,
I am able to see this one. Here we are
mhm,
seeing one column like clusters, right?
This one.
No, no.
This one.
No, not this one. The back end one only. That compute warehouse, system warehouse. Yeah, here we are seeing clusters.
Okay, here, right?
Here, if
Yeah,
you
but.
put the second one, if
Mhm,
you put on second one,
mhm.
uh, it will
Then you can
show, right?
see, yeah, it will show more lines. It will change the
Uh,
colors of the
Here
lines.
for me, it's showing
Mhm.
it running it is using 8 of 20
8 of
clusters.
10. Okay. 8 of
8 of
13 clusters.
20.
Yeah, you
20.
can have even more powerful, right? So for now, these are the features which are seen in the Snowflake, I mean, the trial account. right? We can even have more powerful, we can have even more clusters. So it could be possible that your customers might have requested the Snowflake data warehouse to even create even more powerful Snowflake data warehouse. They can also request for 20 clusters. So over here, the restriction which we have, this restriction is also because of the free trial, right? We could even
Oh,
have more
okay.
cluster than that. So if you want even more features in the productive environment, we can pay more and we can even have more clusters created for us. So it is a restriction in the free trial. It is not a restriction for all the Snowflake data warehouse accounts. So we can have 15,
Okay.
we can even have 20, we can even have 30. I guess this was your question, right?
That is
Okay.
only my
Yeah. And so these all things can be tweaked by the organization. For example, in the development, they will keep only 10 till 10. But production, they want even more powerful. They can even ask the Snowflake data warehouse that they want even 20 clusters to the virtual warehouse. Because in the productive environment, you can think we want it as powerful as possible. So we can request Snowflake data warehouse team to add even more clusters. That's fine. Snowflake data warehouse is happy, right? Because you are going to pay more for more clusters in for the performances, right?
And I have one doubt. If
Mm-hmm.
any one of the query is queued in production,
Mm-hmm.
if more time, then it will stop.
Yeah.
The remaining queries also will be in queue, right? It will
Yes.
impact our production
Yes.
environment.
Yes. Yes. Yes.
Um,
Yes.
to avoid those things, it will
Mm-hmm.
automatically use another cluster to run those queries in real time,
See,
or
all everything is dictated by your scaling policy. If you have a standard scaling policy, it will keep on starting new clusters whenever a queue will come. But if you have something called as economy policy, the economy policy will shy from starting new clusters, right? This is what we have seen. So based on that, it will be automatically done. The assignment of the new clusters, assignment of queues, queries in the queues to the virtual warehouses, everything is done automatically. We do not have direct control over the how the additional cluster will start or end. We just have to provide the scaling policy. Whether we want to perform, whether we want the performance to the priority, or we want the credit saving to the priority. Based on that, once we have set up the second settings, then how the queries are going to be executed, how they are going to get start a new cluster, how the new clusters are going to end, then it is all done automatically by the Snowflake data warehouse. But if you think that, for example, if you see that there are more queries which are waiting in the queue, then maybe it could be an economy scaling policy. You might need to change it to standard scaling policy. You might even add more clusters, or you can even add more virtual warehouses. So we have not seen all these things, how you can play around with these different options. If you have more queries, then what should we do? If you have very large queries, what should we do? What combination we should have for the scaling policy and the virtual warehouse? Okay, this is something which we have not discussed so far. Okay. So we have multiple
okay.
ways. If you see queries waiting for a very long time, for example, if you see there is a query which is waiting very long in the queue, you can think of either increasing the clusters, you can think of increasing the scaling policy, making it better. For example, if it was economy, you can go for standard, or you can, or whether you should go with creating one more virtual warehouse. So all these things we will see what is the solution for what problem. Because these are few,
Uh,
you can also go for query acceleration as well, right? We have seen that.
yeah, query
But we have,
performance also will be we need to
yeah,
consider.
we can consider this as well. So for example, so there could be some query which is, I'm sorry, I closed that sheet. One second.
Yeah,
Uh,
if someone not written logic very efficiently, that time
exactly.
also.
Exactly. For example, there is a step you can also see this. For example, there is a step which is taking a lot of time. For example, there is a step which is, for example, a lot of joins are there. Some people, that is why we call it as sometimes you can go for union. Union is faster than join. So this way you can optimize a query, and then you can see a pain point which is taking more time, a specific step which is taking more time than the usual query. You need to find it out, and then you will have to make it, you will have to optimize it. This is what we do as a part of the database, I mean query optimization, right? So the problem, there could be a problem. First of all, we have to find the problem, where that problem is in the specific step. You can go for the compute increase in the compute resources. If the if there's a problem with the entire query, If the compilation is taking more time, what should we do? If it is taking more of the runtime step, what we should do? Whether you should increase the clusters, whether you should change the scaling policy, or whether you should add additional virtual background, right? So all these things we will see. So how, I mean, this is a part of the future sessions of how we can make our queries even faster based on the use cases.
Oh, okay. Thank you.
Thank you. Thank you so much for your question. Anyone else? I mean, before closing off, sorry, before I close off, anyone has any questions? I guess all good. Okay. Again, thank you so much for joining these sessions. So let's meet tomorrow. So from tomorrow, we will have the proper sessions. So thank you so much for giving us the time to provide the session on the Snowflake Data Warehouse. I hope you like these sessions, and the next session from tomorrow will be paid. Please connect with this Data Vision team, which I had shown over here. Where is that? One second. You can come to the website. You can have a chat with them. You can talk about the fee structure, all these things. I mean, for them, they will be helpful. So you can come out to them, you can provide the details, they will come back to you, or you can also call them anytime. So I have seen that these guys are very, very helpful, and you will be answered with the specific question which you have without taking much of your time. Okay. Thank you so much. So I hope you enjoyed today's session, and this session is also going to the YouTube channel. Let me remind you again, you can come here, you can find more details, you can subscribe, you can see more videos, and also all videos which I have over here. And I hope you all are very I hope a very good successful future ahead for everyone. I hope we all grow together and we have very nice career ahead of us. That's it for now. Thank you so much. Let's connect tomorrow for the next
Thank you.
session of the Snowflake Data. Thank you. Have a good day.